Welcome back to your favorite intermediate algebra course. We're going to look at solving radical equations today. That's our objective, is to solve some equations that contain radicals and then also identify extraneous solutions if they do pop up, okay? An extraneous solution is just a solution from this transformed equation that appears to be a valid solution, but it's really not when you actually check it. It doesn't satisfy the original equation. So make sure that you're checking these as you go along, okay? So let's look at this third root of x minus 4. Well, just like if you were solving x minus 4 equals negative 3, wouldn't you get that by itself first by adding the 4? Okay, so we'll go ahead and we'll do that. We'll add the 4 first. We got this third root of x equals 1, okay? Or in other words, x to the 1/3 equals 1. Same thing if I put that in exponential notation. Now we want x, right? Just plain old x equals something. So what do we have to take this to make it x to the 1, right? I said, well, I got to take that to the third power, right? I got to undo the third root of x. So I got to do it to both sides. Because you see how you get 3/3 there? X to the 3/3, in other words, x to the 1 power. So x to the 1 equals, and then 1 times 1 times 1, 1. So x equals 1 appears to be our solution. Let's go ahead and check it on this one here and just double check. So I have the third root of x minus 4 equals negative 3. The third root of 1. And I say, well, do I have 3 of a kind? Sure, isn't 1 times 1 times 1 1, right? So 1 minus 4, does that equal negative 3? You bet it does. So this works out. Let's do some more here. How about... let's go ahead and solve negative x to the 2/3 equals negative 49. Okay, so here we're going to say, well, let's get rid of that negative first of all. Let's divide by that negative 1 here. So we got x to the 2/3 equals a positive 49. And again, I want that x to the 1 power. So what do I have to take that to make it x to the 1? I got to take it to 3 halves, right? X to the 3. So now you see how you'll have 6/6 on that, which is x to the 1, right? So I got to do it to both sides here, okay? So x to the 6/6, x to the 1 power equals 49 to the 3 halves. And let's go ahead and try and simplify that. So that's 49 to the 1 half. Take the root first before you cube that thing. See how that's 3 halves. So what's the square root of 49? I said, oh, that's 7. And then 7 to the 3rd here is 7 times 7 times 7. Let's see, 49 times 7, 343. Sure, 43. Okay? And you go ahead and check that in the original equation, and it checks out. Okay, it works out for you. Okay, let's do one where you have one radical. Let's solve an equation with one radical. So how about... let's go square root of 3x plus 4 minus 1 outside of that, and that equals 7. Okay? So first you want to isolate this radical. Okay, you see that radical there? You want to isolate that square root of 3x plus 4. Isolate that thing by itself. So get rid of that minus 1 first. So you got square root 3x plus 4 equals 8. Now this is the same as 3x plus 4 to the 1 half, isn't it? Isn't that the same thing there? If you put that in exponential notation, so you say, oh, well, I got to undo the radical, right? I got to undo that square root. So we're going to go ahead and take that to the 2, or 2 over 1, right? Because wouldn't that be 2 over 2, in other words, to the 1 power? So I got 3x plus 4 all to the 1 power equals 64. And make sure when you square both sides, you better check your solutions as well, right? You got some potential here for some extraneous solutions. 3x equals 60, divide by 3, and we get 20, right? And go ahead and you check that in your original. So square root of 3 times 20 plus 4 minus 1 equals 7. What's the square root of 60 plus 4? Square root of 64 minus 1 equals 7. Sure, square root of 64 is 8. 8 minus 1 is 7. So it does check out. Good to go. Let's try some more. Let's solve an equation now with 2 radicals. So let's say Alright, when this occurs, you know, if they're both the same root here, like they are here, you know, you got this, both of them have the square root, go ahead and get a square root on each side and then square the sides, okay? So if you have two radicals, get one on each side. That's your step, okay? So if two radicals, get one on each side, and then in this case, so let's do that, plus root x over 3. So you got square root of 2x minus 5 equals root x plus 3. So how are you going to undo a square root? Well, since that's to the 1/2 power, we're going to square it, right? We're going to square both sides. But again, make sure if you're squaring here, taking each to a power, that you gotta check your solution. Okay, so in this case, undo the radical, so square both sides here, at least in this case. Okay, if they were both third roots, I'd take it to a third power, right? So anyways, 2x, square root of 2x minus 5 times another square root of 2x minus 5 is just 2x minus 5, right? Same thing with that. Square root of x plus 3 times another square root of x plus 3 is that, which is just x plus 3, right? So it sort of undoes that radical, if you will, okay? And then we just go ahead and we finish solving this. So I got to combine my like terms on the one side here. So subtract x both sides. Now I got x minus 5 equals 3. Add 5 on both sides. My answer looks like it's 8. Go ahead and check that in the original solution. Check x equals 8. 2 times 8 plus 5. So 16 minus 5, looks like that's 11. Looks like that's 11. Hey, that checks out. Root 11 minus root 11 is 0. So that checks out. The solution really is x equals 8. So far no extraneous solutions here. Okay. Let's look at another one. How about if we got x minus 2 equals root x? X minus 2 equals root x. Okay, so you're looking at this and you're like, okay, this is funny because I got to get rid of that radical, right? So get that radical. You notice that it's all by itself on that right-hand side. Let's undo the square root. So right now it's to the 1/2 power. So to undo it, I got to square it, which means I got to square this other side, right? So I got x minus 2 quantity squared. So there's 2 of those. And then square root of x quantity squared is just x, right? So now it looks like I'm going to be solving a quadratic, it appears, right? So x squared minus 2x plus 4 equals x. Well, to solve a quadratic, I have to get one side equal to 0, right? After I combine like terms anyways. So get one side equals 0 because I'm solving a quadratic now. X squared minus 5x plus 4 equals 0. Okay, so I got the one side equals 0. So at this point I can say, well, I can run the old quadratic formula, or I can hopefully factor this thing. So let's see if this factors cleanly. That's typically your fastest way, right? So factors of 4, it's got to be 1 and 4. Since it's positive 4, it's either a plus plus or a minus minus. It looks like it is minus minus because if I FOIL it, it'll give me that x squared minus 5x plus 4 if you've forgotten that. And then use the old zero product property at this point. Okay, so it appears that it's 1 and 4, right? So why don't we plug those in? Let's check 1. Does the 1 work? Oops. I'm checking it in the original. Here was the original, right? Does 1 minus 2 equal the square root of 1 when I plug 1 in for x? Is that true? No. 1 is no good. Throw it out. Now let's check the 4. Does 4 minus 2 equal root 4? Sure, that works. So 4 is a solution. So this was a great example of having an extraneous solution, that 1. So it was a solution that when I transformed the equation, and I got 1 and 4, right? When I transformed the equation, that 1 did not satisfy the original equation. So that is an extraneous solution, okay?